We're now looking at parallel lines, perpendicular lines, and skew lines. For this picture right here, we have a bunch of different lines shown, and what we want to do is look at which lines or planes in the figure appear to fit the description shown. So for the first one, we've got lines parallel to CD and containing point A. Well, we've got this line right here, which is CD, and we've got AB is parallel to it, GH is parallel to it, and FE is parallel to it. But we want it to contain point A as well. So parallel to CD and containing point A. The only one that works there is line AB. For the second one, we've got a line or lines that are skew to CD and containing point A. Well, let's look at all the lines that are skew to CD. Skew again means that they're not parallel to CD, but they still don't cross. Okay? So if CD is here, if we look carefully, we can see that EH doesn't cross and FG does not cross, and it's also not parallel. AH does not cross and BG does not cross, but they aren't parallel. And finally, AG is another one that is not parallel but doesn't cross line CD. In this case, there are two lines that are skew and also containing point A. That would be line AG. Hopefully you can see that. And the other one is line AH. Remember, it had to contain point A. So for the next one, we're looking at lines that are perpendicular to CD. And it looks like there's quite a few there. We're going to highlight them. Again, here's CD. And if we look, it looks like DE is perpendicular. It looks like CF is perpendicular. It looks like AD is perpendicular. And it looks like BC is perpendicular. So those are the lines that are perpendicular to CD. There's only one that is perpendicular and contains point A, and that would be line AD. And finally, we're looking at planes that are parallel to EFG and also containing point A. EFG, the plane, is this bottom surface right here. And remember, to name a plane, we need 3 points. So the plane that appears to be parallel would be this top surface right here, and we can call that plane. And we'll just use any 3 letters. I'll use A, B, C. Okay? So there's the answers to that. And I'll go over it again. For the first one, we had line AB was parallel to CD. We had AG and AH appear to be skew to CD. We had AD was perpendicular to line CD. And finally, plane ABC appears to be parallel to EFG. Now, using the same picture, again, we want to look at lines that go through point H and appear to be skew to CD. So again, we had our CD, and we had AH was skew, we had EH was skew, we had AG was skew, we had BG was skew, and is that it? That's parallel. Oh, and FG is skew. But there's only one line. No, there's two. There's two that are skew. They don't cross CD, and they're not parallel to CD. That would be line AH and line EH. So those are our two lines that are skew. Okay, and now we're going to look at another picture, and we're going to name parallel lines, perpendicular lines, and then look to see if FE is parallel to AC. So it's kind of hard to see here, but there is two little triangles or arrowheads here. There's also two arrowheads here for this line. And remember, the arrowheads tell us which lines are parallel. Finally, there's also a box here, and that box helps to tell us which lines are perpendicular. So for the parallel lines, if you look, we've got a line MD there. And because they both have the same number of triangles there, we can say MD is parallel to FE. And remember, to tell that two lines are parallel, we use these two lines close together to show that two lines are parallel. For perpendicular, we can see we have BF there. So line BF, and because of this box here, we know that it's perpendicular to AD. Okay. Now we want to know, is FE parallel to AC? If we look at AC right here, it looks like AC is going to intersect with FE. That would be one explanation why this is no. Another reason would be that they don't have the arrowheads or triangles on AC. Therefore, we know that the lines aren't parallel. And finally, the reason that they give is that if we have this point M, there can only be one line drawn that's parallel to FE, and that's already there, that's MD. So for the explanation, we could say through point M, only one line can be parallel to FE, and that's MD. So since AC also goes through M, it can't be parallel to it. And we'll show that right now. Again, MD and FE are parallel, MD and BF are perpendicular, and as said, those are not parallel because MD is parallel to FE, and by the parallel postulate, there's only one line that can be parallel to FE through point M. And here's one more. We want to know if, let's draw it real quick again. We've got the box there. We want to know if we want to show that AC is not perpendicular to BF. We can kind of look at it and just kind of tell it looks like they aren't perpendicular if we look real carefully here, because right now we know that MD is perpendicular to BF. So again, through point M, there can only be one line that is perpendicular to BF, and that's MD. Since AC also goes through M, we know that AC cannot be perpendicular to BF. So again, A is not on MD, and MD is perpendicular to BF. So therefore, since we know that MD and BF are perpendicular, we can't have two lines that are perpendicular to BF that go through the same point. So therefore, AC is not perpendicular to BF. And that's it. Thanks.